All right, guys. So let's go to question number 2 in exercise 4E. So again, it's a full circular motion sum. Okay. All right. So they say a smooth, solid hemisphere with radius 6 meter and center O is resting in a fixed position on a horizontal plane. Its flat face is in contact with the plane. Oh, so can you see? Can you picture what's going on? So you have a hemisphere, and the flat face of the hemisphere is the circular face of the hemisphere, right? So the flat face, the circular face, is on top of the hemisphere, on top of the table. So which means the curved part of the hemisphere is above the table, right? Can you guys see what's going on here? So draw a good diagram, because the diagram and the forces is what makes this, so critical. Okay, so this is the hemisphere. All right, guys. Okay, so they say here the center of the all right, so the center of the hemisphere is O. Okay, so the radius is 6 meter. Okay, the flat face is in contact with the plane. A particle P of mass 3 kilogram is slightly disturbed from rest at the highest point of the hemisphere. Can you see what's going on? So on top of the hemisphere, you have a particle. Okay, so it's slightly disturbed from rest, so which means the starting speed should be 0. It's slightly disturbed, so like it just starts with the speed 0 from the highest point of the hemisphere. When OP, so O and this is the point particle P, when OP has turned to an angle theta, the particle is still on the surface of the hemisphere. Okay, so basically somewhere over here. And they say the particle is still on the hemisphere. All right, so the angle turned is theta. When OP has turned to an angle theta and the particle is still on the surface of the hemisphere, the normal reaction of the sphere on the particle is R. So guys, the normal reaction, so when there is a contact force, so you have the normal reaction here. So the normal reaction is R. Okay. So they are asking you find an expression for R. Okay. So what are the other forces now? Normal reaction is the contact force, right? So in addition to the normal reaction, you also have the weight, right? The weight is acting vertically downwards always, right? So weight is how much is it? The mass is 3 kilograms, so 3g. Is that okay, guys? Okay. So at this point, it will achieve some kind of a speed. So let's say that speed is v. Okay. So we are supposed to find an expression for r. So guys, in this question, it's the same as the previous case, but the only thing is now instead of working with tension, you have normal reaction. Because in the previous cases, when we were working with rods and strings, we had tension to deal with. So in here, it's the same story, but only you had to work with, you just had to work with the normal reaction. Okay, so the same story again, we will go for the law of conservation of energy. Okay, so first we'll use conservation of energy. Okay, so when we use conservation of energy, how do we go about with this? You need to set a GP 0 level that can be arbitrary. You can decide wherever you want. Okay, so you could take this point as the GP 0 level to make things easier for you, or for this entire sum. It's entirely up to you where you choose. Okay, I'll choose this point. The thing is, if you choose a point like this, you will get some redundant part of a height. Now, when I choose this downward level, because the thing is, both of these particles will have a common part and that will cancel out. So actually, that it's perfectly fine. Or else you can, as I told you, go with kinetic energy gain equal potential energy loss should be perfectly fine here. Okay. All right. So let's draw this line. Okay. So the height we are talking about here is a small height. What about the radius? Do we know the radius? The radius is 6 meters. Okay, so they have told us the radius is 6 meters, right? So the whole thing is 6 meters. All right. So let's apply the by the law of conservation of energy. All right. So initially we have GPE because I have marked my GP level down here. So it's going to be I have initial potential energy. There is no initial kinetic energy. Equals at this point there's only GP because it doesn't have any speed. At this point you have a speed kinetic energy, there is a final kinetic energy and there is a final potential energy. All right, because I'm taking the height over here. Okay. So basically kinetic energy gain, potential energy loss, if we subtract the PE initial from PE final, that's PE loss. Okay. Okay, I think you guys get that. Okay, so let's quickly mark the height. So mgh, mass is 3 kilogram, g into height is 6 meters. Kinetic energy half mv square, which is put with m, so it's easy. Mgh is 6, half mv square. Okay, the speed here is v at this point now. The potential energy is mgh. What about the height? So when it comes to this particular height level, I think you guys can see that is 6 cos theta, right? This height, this particular height. So when you resolve this 6, it's 6 cos theta, this small height. Can you guys see? Okay. All right. So we can cancel out the m, multiply everyone by 2. So I get here 12g. When I multiply by 2, I get here v square. This is going to be 12g cos theta. So I end up getting 12g minus 12g cos theta equals to v square. Okay, so this is the speed at this point when the angle has turned an angle. When the particle has turned to an angle theta, the speed is 12g minus 12g cos theta. All right, so now let's apply F equal ma towards the center. All right, so what are the forces we have? You can see when it comes towards the center, so the center of the circular motion towards the O, okay? So first thing is, let me mark the angle. I can see the angle theta comes here through alternate angles, right? This theta comes here. So you could resolve this 3g towards the center, right? So this is gonna be 3g cos theta. Okay, 3g sine theta comes this way. I don't need that. Okay, we don't need that's not a force that we are required to work with here. I'm only concerned about forces acting towards and away from the center. So these are the only two forces we have to deal with here. So towards the center, you have 3g cos theta, right? Towards the center, it's 3g cos theta minus away from the center is r. 3g cos theta minus r equals m v square over r, right? Okay, so let's input 3g cos theta minus r equals m over radius, guys. I think I told you radius is 6. The radius is 6, okay? So into v square, let's substitute the v square value. That's 12g minus 12g cos theta. It would have been easier if I had taken the 12 out. So anyway, let's substitute 3g cos theta minus r. Here m12 and m6 cancel, so you get here 2mg. Here also 12 and 6 cancels, you get 2mg cos theta because you expand the bracket with m over 6 with both the parts, right? M over 6 into 12g 2mg, m over 6 into minus 12g cos theta is minus 2mg cos theta. Make r the subject, okay, and we need to input the m value, right? So let's input the m value. M value is mass is 3 kilograms. 2 times 3, that's 6g. 2 times 2, that's 6g cos theta. Okay, so I'll take the negative r to the other side and I get here 3g plus 6g is 9g cos theta plus 6g comes here as minus 6g. Is that okay? So I get here the normal reaction is equal to 9g cos theta minus 6g. Okay. All right, guys, moving on to part B. They say the angle to the nearest degree between OP and the upward vertical when the particle leaves the surface of the hemisphere. So, guys, what happens when the particle leaves the surface of the hemisphere? This is really important. So, basically, what they're saying here is this particle doesn't, just obey and go through this. This particle goes through some point and then it leaves the hemisphere. Can you see what they're telling me? You go like this and then you leave the hemisphere. Okay, so basically you leave the hemisphere and you start moving in a projectile path. So that's what's happening. So what happens when you are about to leave the hemisphere? Right, so the most important thing here in part B, when you are going to leave the hemisphere, the normal reaction is the contact force, right? So when you are leaving the hemisphere, the contact force becomes 0, right? When you are leaving the hemisphere, when you leave hemisphere, the contact force R becomes 0. All right. Okay. So let's make R equal to 0. So we currently found R is equal to 9g cos theta minus 6g, right? Okay. So when you leave the hemisphere, the R value becomes 0. When you're about now, at this point, we are considering the point where it's about to leave. Okay. So that means at the very last point of the circular motion. At the very last point where the particle is going through the circular motion. So I get here 6g equals 9g cos theta, g cancels out and I get cos theta equals 6 over 9. That's 3 times 2, 3 times 3. So that's 2 over 3. So you get here the theta value, cos theta is 2 over 3, but I think they want the angle to the nearest degree. So get the answer, cos theta is 2 over 3. And what is the theta value? So the nearest degree, so it means with your cal in degree mode, you type cos inverse 2 over 3. So cos inverse 2 over 3, that's going to be to the nearest degree. Let's get the answer. All right, so theta is 48.1896. It goes on, right? So to the nearest degree, your theta is going to be 48. Now, guys, this is really important. Now, I think you can see we are not done with this. For the next part, we are going to continue with the projectile motion, right? So remember, when you're working with the projectile motion, we do not work with the estimated angle here. Okay, so we always prefer to work with the exact values. Okay, so do not work with don't work with these kinds of figures. Okay, so we will work with the exact figure. So I think that is the reason over here, even in the previous sum, I did not get the cos inverse value and get the alpha, and you don't work with those decimal figures. Okay, so we have to get these answers exactly. Okay, so that's why. So do not go to attempt to do the sum with the 48. Okay. All right, so part C, they are saying the distance of the particle from the center of the hemisphere when it hits the ground. Okay, so basically the particle hits the ground somewhere, it leaves. Now, you need to realize, okay, so when the particle leaves the surface of the hemisphere, what's happening? When the particle leaves the surface of the hemisphere, the particle starts a projectile motion. Okay, so after leaving hemisphere, After leaving hemisphere, the particle moves as a projectile. Okay, so after leaving the hemisphere, your particle moves as a projectile. All right, so how does it go? First thing is we'll have to find the speed of leaving. I think the first thing is to find the speed of leaving. Okay, so let's get the speed. We found the cos theta value. Let's get the speed. So speed of leaving. Speed of leaving hemisphere. Okay, so what's the speed we should leave? 12g minus 12g cos theta. V square equals 12g minus 12g cos theta. I'm taking it from here. Okay, 12g minus 12g cos theta. Cos theta don't use cos 48. Okay, cos theta is 2 over 3. So these are really important things. Do not attempt to use decimals or do not attempt to use the figures that are not exact. Okay, so it needs to be done with the exact figure. So v square, this is the speed of leaving, 12g minus 4, 3 times 1, 3 times 4, 4 times, that's 8g, right? So v square equals 4g. Can you see this is the speed of leaving? So this is the speed of leave. I'll name it as v1 because that's a specific speed, right? Now here what we found as v here was a equation that gives us the general speed. Like at any point you can put any theta value and you can find the speed. So at the point that you are leaving, you have a specific theta value. At the point that you are leaving the hemisphere, there's a specific theta value. So for that specific theta value, we have a specific speed. So that's why I named as V1. Okay, so this is, I don't want to draw on this particle on another place. Okay, I just leave it over here to make things easier for us. Okay, so this is, I took this point as V1. All right, so what they are asking you to do is to find the distance that this particle, the distance of the particle from the center of the hemisphere when it hits the ground. So when the particle comes over here and when it hits the ground, okay, they want you to find this total distance, D. This total distance D is what they want you to find. Okay, but this total distance D, you'll have to find it. As you can see, we can break it up. Okay, so you can see that this distance is already known. This is as you can resolve. This is 6, this is theta, so 6 cos theta, this is 6 sin theta. Can you guys see this distance is 6 sin theta? This horizontal distance is what you are traveling under the projectile. Okay, so basically when you hit the ground, the total distance from the center is the 6 sin theta. Guys, you understood how I took 6 sin theta, right? This side, I just resolved, this 6 meter towards the angle. The vertical one is 6 cos theta. The horizontal part is 6 sin theta. Okay. And the other part is D. This part is not the same. Please do not assume that D and 6 sin theta are the same. There is no symmetry here. Okay. D is not 6 sin, it's not symmetry because the first part of the motion you are moving under circular motion. The second part of the motion you are moving as the projectile, moving freely under gravity. So they are not the same. Okay, so you'll have to find D separately by using using the projectile motion. So over here, I think going with projectile, it's best that you go with the components of speed. Okay, so conservation of energy will not help you to find the distance. So it's better to go with the components. So let me mark all the components so you guys know how it's done. Okay, as you saw me doing in the previous sum. So this speed is V1, right? So this is the V1. Now you need the components. So the horizontal and the vertical component. Okay, so the theta, this is 90. This is theta. Guys, this is 90 minus theta, right? Right, so this angle will be 90 minus theta, which means this angle should be theta. Agreed? So these are some simple geometry things that you need to understand. Theta, this is 90 minus theta. This is again a theta. Okay, so I'll directly mark it now. Okay, so now we can resolve the V1. So the horizontal component is V1 cos theta. The vertical component is V1 sin theta. Can you guys see? We'll erase these speeds, okay? Now I don't need them. So this is V1 sine theta, the velocity component downwards, okay? All right, so this is the starting speed. So at the ending point also you will have components. So I'm not gonna go with them. All right, so my task is to get the D. So guys, what we can do here is over here, the easiest way to get this done. Okay, so what's the easiest way to get this done? All right, so let's find now. So the best thing to do here is I believe we go with in part C. Okay, we are in part C. So you can apply. So if you go with other equation, V equal U plus AD, V square equal U square plus 2A, those equations involve the final velocity. Final velocity is the speed, the velocities that are involved when you're hitting the ground. And you can see the speed of hitting the ground is unknown. And also the two components are also unknown. So it's best that you go with the equation that doesn't involve V. The only equation that doesn't involve V is S equal UT plus half AD square. So I'll apply it downwards. So guys, over here from the start of the projectile motion to the end, I think you guys can see we know the vertical displacement, right? So the vertical displacement is known. Is that, can you see? So this is the particle is vertically displacing how much of a distance? From this point down over here, it vertically moves a distance of 6 cos theta, right? Guys, can you see this distance is the vertical distance. Now from the start of the circular motion until you hit the ground, the distance, the total distance you move is 6 cos theta. Agreed? So S is 6 cos theta. U is the speed, now remember we are working with the component of speed, okay? Don't put the speed, so put the proper component. So the component here at the beginning, U is V1 sine theta. And that's also acting downwards. That's fine. Time is unknown. Plus half G is unknown. And again, T square. T is unknown. Agreed? Let's try to go with this. 6 times cos theta is 2/3. Guys, we need to get the sine theta value. And V1 value, do we? Okay, wait. Give me a moment. Yeah, I think we'll have to deal with decimals here. Okay, anyway, V1 is 4G. V1 square is 4G, so which means V1 is root 4G. Sine theta can be found since cos theta is 2/3. You can apply trigonometry, and here remember theta is an acute angle. So you all the theta value, cos theta, sine theta should be positive. Okay, so you can use sine square plus cos square equal 1, or you can use this technique, cos is adjacent over hypotenuse. Right, so that's 3 square minus 2 square. So 9 minus 4, that's root 5, right? Agreed? So sine theta is opposite over adjacent, opposite over hypotenuse, that's root 5/3 into t plus half gt square. So guys, I think over here we will be, we get a quadratic equation of t, but I think, let's see if we can find the exact figures or not. Okay, so I get here 6 into 2/3, that's 4, right? I get over here root 4g into root 5, that's root 20g/3 times t plus half gt square. Guys, can you see? So we get a decimal kind of, we get a quadratic equation here. I'll multiply everyone by 6 because of the denominator of with 2 and 3. 2 and, yeah. So I get here 6 times 4 is 24. 3 times 2, so it's 2 root 20g times t plus 3gt square, right? All right, guys, so we have a quadratic equation, 3gt square plus 2 root 20g times t minus 24. So guys, when you use g as 9.8, you will be getting decimal figures here. So this is as far as we can go with exact. So I think in the question, they might have said to get the answer to figures. Okay, no. But you'll have to go with decimals here. I think regardless, you cannot escape getting decimals. Okay, so at this point, When you use GS 9.8, you can get a quadratic equation, type ABC in the calculator, get the answers for the quadratic equation. You can immediately get it now in M3. You can directly type the coefficients in the calc. Okay, so A is 3G, which is 3 into 9.8. B value is 2 root 20G, which is 2 times root 20 into 9.8 inside the root. And your C value is minus 24. You don't need to write the ABC. I just wrote it to make it clear to you. Can I know the two T values? You should get two T values in your calc. Okay, and this is going to be decimals now. So let's take a little bit extra decimals. And then when you use GS 9.8, final answers must be given to 2SF or 3SF. Okay. Okay, so can I know the two T values? So guys, here these are the two T values with the cal. So definitely T is not negative. So you understand T should be the positive value, right? So this is not possible. Okay, T is not negative. Okay, so T is positive. Therefore, T should be 0.545124341. Okay. All right. So we can't get rid of the decimal. We'll have to go with it. Now let's go with the get the horizontal distance that you travel, the distance D traveled under the projectile. So you'll have to again use what? S equals UT horizontally. So you know when you use horizontally, the acceleration part doesn't come, right? Do you recall M2 projectile? Acceleration in the horizontal direction is 0. So you only have S equals UT. So the horizontal distance traveled is D. Under the projectile, the distance traveled is D. Okay. U is the V1 cos theta. And time we found over here 5 point. Okay, let's just keep it as D and input it at the last moment. So D equals V1 was root 4G. Cos theta value is cos theta value was 2 over 3. So into T value is 0.5451241. So how much is it now? Get this answer. All right. So the D value is so 4 into G is 9.8. It's inside the root 2 over 3 into this value. And you get the D value. So then the question is, the question says to find the distance of the particle from the center of the hemisphere when it hits the ground. So distance of the particle from the center of the hemisphere when it hits the ground is the distance from O is equal to 6 sine theta plus the D. So 6 times sine theta, the sine theta value. We found, right, sine theta was opposite over adjacent. So root 5 over 3. 6 sine theta plus the D value, 2.27534340. Yeah, just give the whole thing. And then final answer, we can give it to 2SF or 3SF. How much is it? 6 into root 5 over 3. Yeah, plus the D value. So let's get the final answer. All right, guys, this is what we get in the cal, but you should not keep this answer when you use GS 9.8, and we have done some approximations here by using GS 9.8. So definitely leave your answer to 2SF or 3SF. That's a requirement. So in this case, it's going to be, I'll leave it to 3SF, 6.75 meters, and specify your significance. Okay, so I'm say the significance. It's 6.75 meters to correct to 3 significant figures. Okay, so otherwise you could say if it's 6.7474, you could even say the answer is 6.7 meters corrected to SF. Okay, so any one of these two answers are okay. Just leave one of them. Don't leave both of them. Either 6.75 to 3SF or 6.7 from here. Okay, so you look at the original figure, 6.7 to 2SF. Okay, so one of these two. You don't, please do not correct the 2SF by looking at the 3SF corrected figure, right? You know the rule. You should look at the original figure and write it to 2SF or 3SF. So any one of the two answers are okay. All right, so I hope this part is clear with you. So these are the main things you need to know when it comes to vertical circular motion. All right.